Hello everyone, it's indeed inspiring to see you back again, and I welcome you all to the sessions of Apache Flink. In this particular session, we are going to discuss about the MapReduce, and from MapReduce how basically things got evolved and developed and how Apache Spark came as a solution, and then why did we actually require Flink. So this is how the whole journey I am going to discuss with you, and I hope you will like this particular journey. So let us start here. Let me add a new slide over here, and in this new slide let us write the journey. Okay, so the journey journey from MapReduce to Spark to Flink. Okay, so there are so many tools which will come into picture. Okay, don't worry that it's not the only tool. So multiple things we will have. So let us have a look at this particular image. So here you can see that I have drawn how MapReduce actually happened and how MapReduce was helping the whole of the processing mechanism. So in case of MapReduce, if you see that we have a client and client submits a job, and after submitting the job, what client does, client basically then waits for the resource manager to accept that particular job and schedule it with the help of schedulers. This is what actually the client does. So in all of these mechanisms, what every how things were happening, so let me help you with those things. So here you can see that when client is submitting a job to the resource manager has got two important components. One is scheduler and other one is application manager. So scheduler helps in scheduling the job and the subtasks, and application manager is that component which actually initiates one application master. So here you can see that this is application master. This application master gets initiated inside one node manager, because a node manager is actually responsible for running out the slave tasks or the tasks which are actual execution tasks. So that is the task of the node managers. So let me give them a different color so that they are easily identified. So these are the node managers which basically are responsible for actually executing the task. But who will execute? Application master will execute. And this application manager is helping out to initiate the application master. Okay, so that is how it is happening. Now what happens over here, that when this job is getting executed, the application master can request the resource manager for getting more resources or the required number of resources so that it can complete the job. If something wrong is happening, let's say some executor slot is not working or some task is getting failed, so application master keeps on giving the updates and reports and status also. So that is also the work of application master over here. So this is how we have seen that how in case of yarn architecture how MapReduce actually works. Let me take you to more journey. Here you can see that in this particular case, whenever this whole journey starts, then what exactly happens? So in this whole journey, if you see that we have data nodes, and data nodes are having disk spaces. Okay, data nodes are having disk spaces, but if you see that the whole of the blocks, they are actually getting stored into this disk space, and whenever some processing needs to happen, then these block they need to come. Okay, so let me give them a different color first. So we have these blocks also. Okay, so I think they are lying behind it. Yeah, so these blocks, if you see, these blocks are having they need to come into the memory. Okay, these blocks come into the memory. So once they come into memory, then what happens, then basically the first task, that is map task, that gets started. So in MapReduce, the block is coming from the disk to the memory, and the map task is getting started. So here you can see that map task is running. So after the map task is successfully completed, it will give some output. So here you can see it is giving some output. Task 1 and task 2 are running, and they will give some output. Okay, so when the output will come, that output will actually go where? That output will go back to the memory. So op1 and op2 here are the outputs which are going to the memory. You can see, so these outputs, they went back to the memory. Now, when these outputs are there, then reduce task will start. So reduce task is going to pick up those outputs and give a final output. And this final output is again going to store into the memory only. So finally that final output is also going to get stored into memory. Are you getting what is happening here? If you see that what exactly is happening in this whole scenario, that the data is coming from the disk to memory and memory to disk. This is what is continuously happening. So let me explain you here that when we are having data coming in this particular manner, so this part, this is first stage, which is disk, okay, and then we have second stage, which is memory, okay. This one is disk, and second we have is memory. So data went into memory, okay, and then again from memory, this is in map, okay, maps output again goes into disk. So do you really think that these operations are worthy? And again from disk, this data is going to get into memory again in reduce task will take that into memory first, and then after execution whatever is the final output will go into disk. So are these IO operations really required? Okay, so in MapReduce they are required, but are they not consuming so much of time, so much of network bandwidth also, like by traveling from disk to memory? They are. So this is one of the major challenge and a bottleneck in case of MapReduce. So what happened after that? After that, there was a notion which came into existence, and this notion was that why not to have the disk storage capacity where we are storing the whole of the data? Why can't we do one thing, that we can reduce the size of the disk capacity and we can increase the size of the primary memory? Can we do that? So that was a thought process which came into existence, and that really happened. So we actually increased the size of the primary memory. You can see here that we increased the size of the primary memory, and we thought let's basically try it out. So we increased the size of primary memory, and the external storage, not external, the disk storage, that was kept only for backup purpose. And so this was quite expensive. Like we have a tool called as SAP HANA. So they basically started doing this thing. They were the very initial stage. They actually started out these particular things, and they got success also. But if you see that SAP and all the tools which are coming from SAP, they're very expensive. So they did this, but the solution was not so accepted by all the companies, because each and every company can't go for very expensive solutions. But this is a solution, okay, this is a solution. With time what happens, the computer hardware that keeps on getting reduced in cost. So over the period of time, we will have better infrastructure with the budgeted cost. So that is an expectation we can have. But this is a solution. When we can increase the memory size, then it will not be required to bring the data from disk to memory and from memory to disk again. That won't be required. Till the time the data is getting processed, keep it in memory only. Okay, don't bring it into the disk. When you have the output, you want to store it, you bring it to the disk or a database, wherever you want to store it, you can store it. So this is how it was happening. Then this is a case which happened in case of Apache Spark. So what Apache Spark did, Apache Spark came up with a concept of RDDs, that is resilient distributed database. So this resilient distributed database in Apache Spark, they are spread across multiple machines. Now you are already aware of the data nodes and the blocks inside data nodes which are stored. So RDDs are very much similar, but these RDDs, they do not get stored into the disk, but they actually get stored into the memory. That is the difference. So when they are in memory and they are getting processed, so at this particular point of time, they are actually just getting processed from memory to memory only, and final output we are getting displayed on a terminal, on a shell, wherever, whichever IDE you are using, there you will get the output. Now if you want to store it somewhere, you have APIs, you can store it somewhere, maybe on the local file system, on SDFS, somewhere you can store it. So this basically changed the whole scenario. Like when Apache Spark was used, it was running around 10 to 100 times faster than Apache Hadoop's MapReduce. So that was a transformation which basically Spark came up with. That's why the name is Spark, lightning fast unified engine. Okay, so that is how Spark actually came, and it transformed a lot of things. It actually uses the available options which we have. So what options do we have? We have options of the for file system, we have local file system, we have SDFS. So all these available options we have, it leverages them, it has been using them, Apache Spark, and it proved itself, and it has been very much being used today also in the industry. Now, if you see the whole of the technology stack of Apache Spark, so here you can see that the lowermost layer is of the file systems, and these file systems can be SDFS, local, cloud, and then if you want to deploy and run Apache Spark, you can run Apache Spark on top of Mesos, you can run on Spark Cluster Manager, EC2, Yarn, all these options are there. And a native library which is required to run Spark is Spark Core. Then we have APIs which are basically helping us with Python, Scala, Java, and R, and they help us for Spark SQL, Spark MLlib, streaming, and R and graphics. So this is something they provide support to. So this is the whole technology stack Apache Spark provides to us. And with this, basically, let us now try to understand more on it. We have understood the capacity and capability of Apache Spark till this point of time. Now, let me tell you something more. What kind of demand was actually getting generated, and which had to be supplied? So, this new demand which is getting generated and which has to be supplied, so this demand is basically of real time analysis. But if you see that, the kind of machine learning models we are developing, the kind of algorithms we work into, so what they require is they require some past data, previous data. So let's say you have past data for many days. Here you can see that for lot many days you have the past data, and you are trying to analyze it. So this is past data, and you are creating a model here. So let's say this is the model, model. You created a model over here, and this particular model is now trying to make predictions. So it made a prediction that all of these days most of the interest people were having was into comedy. So this was a prediction it gave. But that is not the only requirement which we have today. We actually have a requirement that data is coming, you should able to quickly do the analysis and give the result within microseconds. You actually need to do this. So how come this is possible? So this actually became a possibility with the help of certain tools. Let me help you how. So the scenarios I'm telling you that the kind of requirement, the kind of demand which we have. So here you can see I have portrayed first case. The case one is basically of batch streaming. Okay, so this batch streaming, if you see that in this particular case the data is there, the data is coming as a real time streaming into SDFS, and here you can see that this real time streaming is the demand. This is the demand which we have. So if we are basically collecting data in this particular way, that lot of data is coming and we are bringing that data once in a while and putting into SDFS, is this going to help us out with real time analysis? Is this going to help the OTT platforms or the video based platforms, e-commerce platforms to quickly give the real time marketing plans to the customers? Can they dynamically at runtime, based upon the user behavior, change their product listing in the next page? Is it possible? The answer is no. Obviously, it is not possible. So, if you see that the kind of demand which we have today is real time streaming data analysis, that is the demand. So I hope you I was able to help you out with certain concepts, and I was able to generate a curiosity that what kind of demand do we have today, and this is the modern architecture, industrial architecture actually demands. So keep watching. We will have so many discussions, so many practicals in the upcoming videos. I hope you like the Flink series videos, and if you have any kind of queries or questions, please do write us in the comment section below, and try to share this video to as many as possible. And if you haven't subscribed to our channel, please subscribe.